In this video, we're going to be going through the practice exam for the third exam coming up this semester. Remember that this is covering chapter 6 and chapter 7, and there's a brief list of just the topics that are in those two chapters at the bottom of the front page. So starting with the true-false, given a function f, then what is f of negative x? It's not the reflection over the y-axis, over the x-axis, so it's false. This is the reflection over the y-axis. I make all of the inputs negative. I'm switching it across the vertical axis and not the horizontal, which is why it's not true. If g of x is x and f of x is the square root, we're asking if these two are equal to each other, and I would just compute them. F of g of x is, by the definition of how the functions are defined, g of x is just the function x. It's pretty easy. So then this is just f of x, and that's the square root of x. That one's very, that seems almost too easy to compute. It's just because the function g is just x. Whatever you put in for input, you get that back out. Maybe that gives us a hint here that these are actually equal to each other. If I do g of f of x, then this is g, f of x is the square root, and then again, the function for g, whatever I put in, I get precisely that back out. In both cases, I get the square root, and so this is true. Another way to see this is that this function g is a little bit special. Right, it's like just equal to x. Anytime you compose the function with x, the function just x, you always get back what you start with. So that's another reason why these will be equal to each other. Okay, let f of x equal x squared plus 5, and we're going to consider this other function. Is this the transformation that was applied? Well, we can realize that we can write g of x as f of 2x, right? And maybe you don't have to do this. It might be helpful though. And just to check that this actually works, if we put 2x into the function for f, we get 2x squared plus 5, and that's exactly this. So I do have the right formula here by saying that g is f of 2x. That is a horizontal scaling. What we have in this class, we're saying here that b is 2. And is the compression? Well, what this statement means is that g is f with its inputs multiplied by 1 over b. We flip it when we have this here. And so if I then consider the function g, well, if I consider f and I multiply all of its inputs by 1 over b, and here this is 1 over 2, so 1/2, then the function will be compressed. And so the answer is yes. One way to decompose this function into two, okay, so we can check that this works or doesn't work. So if I do f of g of x, this is f of, well, g is ln of 1, and ln of 1 is 0. So this is f of 0, and it should be pretty clear that that's not going to work. It's actually not even defined, because it would be saying it's ln of 0, and that's not even defined. But further, g of x is just a number, so that's also a strong indication that that won't work. So this is false. If you want to correctly decompose them, you could do f of x being ln of x, and g of x you could pick as x plus 1. And if you pick these two, then it will work. Right? Almost immediately, you can see that it will work. But how it's written, it will not. Okay, value of log 5, -10, no. this isn't even defined. So it's certainly not equal to -2. It's not even any number, right? It's just not defined. If you try to do it on your calculator, you will get an error. In general, we can't, if we want to do log of b, any base of x, we have to have x being strictly greater than 0. So namely, if it's negative, it doesn't work. It also doesn't work if it's 0. If f of 3 is 2 and g of 6 is 3, then what is the composition? So if we want to find it, f of g of 6 is f of, well, g of 6, just the way it's defined, is 3, and f of 3 we're told is 2. And so this checks out, and that is true. Obviously, you can't find the formula or anything. You don't even know what these two functions are. But you can check that the points work. Okay, shifting this graph to the right by 2, do we get x squared plus 2? We do not. If we want to shift it right, what we would actually get is, well, if I want to shift 2 units to the right, I have to subtract 2 units. So this would be what you would get, and that's not this. This is actually up by 2, not right by 2. And either way, it's false. This equation is expressed in log form as log base 2 of 9 equals 3. This is almost correct. What we would want to say, so it's not true. What we need here is that the base needs to be the subscript, which is base 3. Whatever number you put in has to go inside the parentheses, it's like the input, and the exponent is the output, and so it'd be 2. So this is how we would correctly say this. Or in terms of the definition that we have in the text, log base b of x equals p means that b to the p equals x. So you can compare these two, but in either case, this would be the correct representation. Okay, fill in the missing values in this table. So this is asking you to go through to use the way that these two functions are defined in order to get what the composition is f of g of x at each point. So to get the first one, I need to do f of g of -1. So I need to put in negative 1 into the function, into the composition function, just like in the same way that this is f of -1. And this is g of -1, right? It would go the same way. I would get my f of g of -1 value here, but I have to find what that is. And so that's kind of where the work in this lies. So I first need to know what g of -1 is, but we actually just pointed that out. It's 3. And so this is equal to f of 3, because g of -1 was that number. And then I need to find 3 in the table. So I'm looking here for the input. The output is 5, and so my answer is 5. And then I would keep doing this as I go through. So this is f of g of 0. So I need to do g of 0 first. That's, well, I find the 0. It's the one right above it. -1, and then x equals -1. The value for f is 8, and so this is 8. This is my second one, and we can keep going. It's very similar. So that's 8. I want here f of g of 1. G of 1 is 2, and then f of 2. So this would be, I should have written f of 2 here. And f of 2 is 7. X equals 2, f is 7. So that's the value. And then f of g of 2, look at the table, is 1. So I'm looking for f of 1, and f of 1 is 0. And finally, then f of g of 3, well, the value for g of 3 is 0. It's the one right above it. Coincidentally, that doesn't have to be the case, but is here. And then we're looking for f of 0, which is, that gives us 1. Would be the last value. Okay. Given this function x cubed, what transformations were applied to obtain this? Well, you can just start to do these questions. Another strategy might be to write out what this is in terms of f. So we can see that we're multiplying, we're still taking something to the cubed to the third power, but we're multiplying it by 2, and so this is a good indication that there's a 2 in front. And then what we're putting into the function is whatever is being cubed. Because if we raise it, if f is x cubed and I end up with x minus 5 cubed, then that has to be the input to the function. And so I then know that I have x minus 5, and then what I have left on the end here is the plus 1. And so what we can see is that this is the representation for the transformed function, the new one that we obtained, the y equals, in terms of f. And this makes it a little bit more clear what's going on. Now we can recognize this form. We're multiplying the function by 2, which means we're vertically expanding it by a factor of 2. So it's not d, because that's vertical compression, and it's not b, because that's also vertical compression. So it's between a and c. They both have shift up by 1, which is true. So then the question is it shifted right or shifted left? And it's shifted, well, we're subtracting 5, so it's being shifted right. So the answer is A. You don't have to write out this in order to answer that, but it might help you, potentially. It might be helpful for you to do. Which of the following is equal to this function? So we have to know how to convert these. This is something like a times b to the x, and what we want to end up with is something like y equals a, and it will be the same value for a, e to the power of k x. Why do I know that I'm converting it? Because there's really no other useful way to write something in terms of a b in the base, but also all of the choices are base e, so maybe that's more of a better hint that you need to do this conversion. And in order to do this conversion, the way that we do it is by realizing that k is ln of b. And this has to be the natural logarithm. This isn't like you can do any base you want. You have to do ln. And so what we would do here is compute the natural logarithm of the base of the function, and that's 0.459. And if we do that, we get d. The value here is the negative 0.7789, and that's what goes into the formula. So then our function is 10e negative 0.07789x. That would be it. If you got, let's see, if you got part B, you may have been adding 1 to k. So the value that you get for k just goes into the formula. You don't add or subtract 1 from it. That may have been why you've been getting that answer. So just be very careful about that. But actually, as a matter of fact, D is the only answer that it could be, because this function is decaying. Its growth factor is less than 1, and the only function here that's decaying is D. These are all exhibiting growth. They're all increasing. So even from just that observation alone, the only correct answer would have to be D. It's the only one that has a negative decay rate, a negative continuous decay rate, so it's the only one that's decreasing. Okay, write this function in the form a e to the kt. So we're doing pretty much the same problem here again. K is the natural log of b, as we just did. So I compute the natural logarithm here. The base that I start with is 1.025, and if I do that, I get 0.0247. It's just a calculator question to do. And now this means that the function is 10, same initial value, times e to the 0.0247 t. So remember, you don't add or subtract 1 to k. Whatever you get for the value, you just put into the formula, and that's it. Graphs of these two functions are given. So this is asking you to find the composition values. And as a reminder of what this notation means, g circle f of x is defined to be g of f of x. So you can think like the left side is the name for the function and the right side is the formula, if you want to think about it like that. And then conversely the other way, of course, right? F circle g x, or f of g of x is f g of x. Okay, so we need to use that here. And this is very similar to the question before with the table at the start of the page 1 or 2 ago. So this is g of f of 0. That's not your answer, and you cannot leave that as your answer. You have to find what this number is. But I can find f of 0 on the graph. That's this point here, and the output value there is 2. So this is computing g of 2. And okay, I looked for x equals 2 on the graph, and I'm up here, and I have that value is 5. And so the answer to the composition here is 5. And that would be your answer that you would provide. And then we can keep going through. This is f of g of 2, and g of 2 is 5. We actually just did that. So then it's f of 5, and f of 5 is down here at 0. The output value is 0, and so we get 0. Fine. G, and this is then g of f of 5. F of 5 we just found was 0. Of course, you could look back at the graph. That's totally fine. It's just we did it in part B. And then we want g of 0, and g of 0 is this value here at 4. Okay. And then negative 2. So then f g negative 2. G of negative 2, I look at the graph, and I'm up here at 3, and so this is f of 3, and f of 3 is 2. Kind of the point right there. And then f of g of 0 is f of g of 0 is at 2, and so this is f of 2, and f of 2 let's see, no, g of 0 is not 2, I'm sorry, that's 4. And then f of 4 is 1. Sorry about that, it should have been, yeah, g of 0 is 4. Right there. And then f of 4 is at 1. And so these are the numbers for the compositions. What is the exact value of this logarithm? You can compute this on your calculator if your calculator allows for any base logarithm, but that's not actually necessary here. You can do this exactly just by hand because we can recognize that 1 over the 5th root of 6 is 1 over 6 to the 1/5. That's actually nothing to do with logarithms. That's just the exponent rules. How we convert between what we're doing in section 4.2, converting between radicals and fractional exponents. And this is almost there, but it's not quite good enough. We can do one more step, is to write that as a negative exponent because we have a fraction. We have 1 over the number. We can bring it up top and make the exponent negative. And then now it's very clear what the value of the logarithm is. I have the same base logarithm, and I'm putting in an exponent with the same base. And so the answer is negative 1/5. And that would be that number. Yes, you can do this on your calculator. You won't be able to entirely rely on that on the exam for maybe because your calculator doesn't allow base 6 logarithms, and then you would have to change the base or something, which is a little bit more complicated. But also you need to know this property in general. There's questions later that require it, and so if there's variables involved, of course, you can't just do it on your calculator. Okay, decompose this into two functions so that y equals f of g of x. So we're picking g here to be the inner function, or the inside function, and then f to be the outer or the outside function. That distinction is important. You can't switch them. Your answer will be incorrect. So I look at the function and I can think the inner function for g is what it's what you should determine first. But you can think about it as what do you do when you plug in numbers to the function? Well, if I want to evaluate this in a number, I would put in some number here, and I would then add 3 to it, and then I would take the square root, and then I would divide it, do 1 over the number. And so one option that we could take here is to kind of just go through those steps. The first thing I did was add 3 to the number. I can choose that to be the inside function, and if I do, the other steps I have to do in order to get to the whole thing is to do 1 over the square root of that. And so this would be this is one pair that would work. There is another option, which is there's just more than one right answer. I could skip to the middle step where I did the square root, and I could treat that as my inside function. And then if I do, the only other thing I have left to do to get back to where I started is to flip it and do 1 over x. And so this would also work as well. You don't need to provide both. Only one is sufficient. But there's more than one right answer to do. What you cannot do is just to say, and this is the instructions, to not just choose the function f or x, because then you would just have, you wouldn't, like, yeah, this is always true. This is like related to the true-false question before. You can't just do this. You haven't done anything because this is still what you started with. You didn't decompose it at all. So this you can't do. But either one of these are okay. Either one. Okay. Compute these following numbers. So now we're composing these two functions together. That's the first step. So remember, this notation means that we're finding f of g of x. So g of x is the input into the function f. G of x is x squared plus 4x plus minus 3. And so that just goes into the function for f. Okay, and then what does f do? You take 3 times the input and you add 2. So you replace the x in the formula with f, with what you put in. So then this is x squared plus 4x minus 3 plus 2. Maybe that should be in green still. Plus 2. And then you need to simplify this out. So then I multiply the 3x squared, 12x minus 9 plus 2, or 3x squared plus 12x, negative 9 plus 2 is minus 7. And so that would be my composition. Now what happens if I do it in the other way? This is the case here, and it is the case in general, that these will not be equal to each other. You do have to do this out. And what this means is I'm putting f into g, so I'm going the other way now. And what do I get when I do that? Well, according to the function for g, I square the input, then I add 4 times it, and then I subtract 3, and we're just going to do that. So I would take the input that I have, which is the 3x plus 2, and I would square it. That's the first step. And then I would take that and I would do plus 4 times the input for the function, which is here 3x plus 2, and then I would subtract 3. Now I need to expand this out. So this is 3x plus 2, 3x plus 2, right? I square it. Plus, and I can start to simplify what's on the right hand side. I can distribute the 4 in, and I get 12x plus 8 minus 3. So the 12x plus 8 is, 4 times 3x, then plus the 4 times the 2. And then I can FOIL out on the left. So then I have 9x squared plus 6x plus 6x from the inside terms, and then plus 4 on the last term, plus 12x. 8 minus 3 is just 5. And finally, I can combine like terms together. I have 2 instances of 6x, so I have 12 times x. And then I have another 12x actually, so I can just write that as 24. Right, 6, 6, and 12. And then I have 4 and 5, so that's plus 9. And this is my answer. So this one's a little bit more work. You have to expand the quadratic out to simplify it. But we can definitely see that these are not equal to each other. And that's okay. In general, they won't be. The point is you have to do the work out to find that. Now, once you have that, you can do part C in 2 different ways. And this is explained in the solutions as well. You can either do this by using the formula that you just found in part B, or you can do it a different way. So let's do it by the part B formula, right? If I found g of f of x for any x, then I can just put in 2. And so what this means is that I'm putting 2 into the function that I just found. 24 times 2 plus 9. And 9 times 4 is 36. 24 times 2 is 48. 48 plus 9. This gives me 93. That is one approach. The other approach, so of course you don't have to do both, but another way to do this is to just directly compute this number, g of f of 2. This is identical to what we did at the table and on the graph question before. Well, what's f of 2? I put 2 into the function for f, so I have to go way back to what I started with. I put 2 into that function for f. I do 3 times 2 plus 2, which is 8. So this is g of 8. And now 8 is the input for g, and so I put g into the formula for, I put 8 into the formula for g. So 8 squared plus 32 minus 3, and that actually gives me 64 plus 32 minus 3. This gives me 93 as well. And so you get the same number 2 different ways. If you are not confident on your formula in part B, maybe don't use it to do this. That's up to you. You can do it either way. This requires that if you do this approach, it has no dependence on what you got here. You get that right or wrong, whatever, at least you can still find that value just using the definition of the 2 functions. So you can pick which one to do, obviously. I'm just saying that maybe if you're not confident on part B and you maybe aren't sure if your formula is correct, you can still have a very solid chance of getting the question right by doing it in this way. It's up to you, I suppose. Okay, so fully expanding this logarithm out. So what we need to do, so what this means is that you don't have, so you should have no products, powers, which we know now, including any radicals, right? Any roots, so namely the cube root there can't stay. Products, powers, quotients, anything like that in logarithms. So we're going to expand it. We'll get, there's 3 terms here. We'll get a sum of 3 logarithms. They need to have they can't have powers, they can't have products in them, they can't have quotients. They need to be sort of simple in that sense. And that's what this means to do. Okay, so how do we do this? Well, the first step would be to convert everything to a power, and that squared is fine. The y we can write as y to the 2/3. Right? The cube root is the 1/3 power. We're squaring the term 2/3, and we multiply that with the z to the 6th. And now that we have them in terms of all the powers, we can apply like the sort of like the power rule, I guess you can call it. Like if you have something like this, you have a variable to a power, it's p, the exponent goes in front, it moves in front of the logarithm, keep the same base of 6, and then you have log b events. And so then we can do that here. But in order to do that, as you can see, we can only have one instance of the variable. We can't have sums or products in here with other things. We just have to have it alone. So the next step is to use, before that step, we need to write it as log x squared. We need to add them up using, this is using the rule that log base b. So say I just have two numbers like x and y. Yeah, they're powers here, but that doesn't matter. Then we can write this as log base b plus log base b of y. So products in the logarithms become sums of logarithms. So we're left with, and we can do this for each term. Now, what we can do here is then apply this rule. And if I do that, so this isn't simplified enough because the terms inside of the logarithms, like I wrote, have powers in them, and that's not good enough. So we need 2 times the log sets x. All these powers come in front. But I can only apply that because I fully expanded it out. I couldn't just have done that from the beginning with how it was written. And then what I'm left with is this. Just fully expanded. There's each term in the logarithm is only x, or right, it may just be only a number, that's fine. There's no products or powers or radicals or anything like that, and so that's what we mean by like fully expanded. Okay. Size of a population increases exponentially. This is its formula. What is the doubling time? So in order to solve this, what we need to do is set p of t to twice. It's twice because it's doubling. If it was the tripling time, it would be 3. If it was the half-life, it would be half. Right? Twice the initial value. Okay, and well, the initial value is 350, and twice that is 700. So we can say then 700 equals 350 times 1.0567 t. You can always do this. You can kind of skip this step maybe if you want, because what happens next is that these numbers cancel out, and well, we can divide them over, and what we end up with is that 2 equals 1.0567. And so if you want the doubling time, these numbers should all kind of coincide. It's not a coincidence that we end up with 2. You could probably skip to this step if you're confident in what you're doing. And then the next step would be to take a logarithm of both sides, but really you should use log, meaning base 10, or ln, meaning base e. Why? Because you need to get a decimal number. If you do it in another base, it's not even obvious what other base you should use. But if you did, then you would have to convert it back using change of base or carefully do it in your calculator, and that's not really worth it. So just do one of these bases. Okay, so then what do we get? So let's say we do ln. That's what the solutions have. So ln of 2 equals ln of 1.0567 all to the power of t. We can apply the exponent rule we had before in the previous problem. If we have a power inside of a logarithm, it comes out in front. And so we have ln of 2 equals t ln 1.0567. Now at this point, this is just a simple equation. We have numbers on both sides. We can compute them now. That's fine. But it's just numbers. And so if we divide by that on both sides, then what we're left with is ln of 2 over ln of 1.0567. And this is approximately, well, this is the exact answer. This is about 12.5682, and the units of the doubling time have to be days because the function's measuring in days. This is the exact value. And then obviously the decimal is the approximation. So about 12 days, a little over 12 days to double. Okay, next function. So determine the formula for g in terms of x. So you need to simplify it a little bit, where these are the transformations being applied. So if I want to shift the function right by 2, then I need to subtract 2 from the input. So this is f of x minus 2. And if I want to shift it down by 1, then I would subtract 1. And this is in terms of the function f, but that's not what this was asking for. I need to compute the value, and that would be x minus 2 cubed minus 1. This is just putting this number into the function for f. This value, this expression. And so this would be your formula here. And then compress vertically by a factor of 3. If we want to compress it, we have to multiply all of the outputs of the function by a number less than 1. We actually multiply it by 1/3. So 1/3 f of x. There's no horizontal or vertical shifting, so I'm not going to have any constants on the end. But the other part of this is that I'm reflecting it over the y-axis. And to do that, there was a multiple choice question before. If we want to reflect it over the y-axis, then we need to make the inputs negative. And so actually what I'm doing is doing f of negative x, and that's taking care of the reflection. There's a true-false question about that. And then if I want this in terms of x, I have to put negative x into the function, which means I would do negative x cubed, and I have to keep the negative there. If you move the negative out, in general, you're going to get something that's incorrect. It has to stay with you. And this can totally be your answer. If I guess you want to simplify it a little bit more, you could take out the negative, because cubing a negative number is just negative, and so this is negative 1/3 x cubed. That's not really required. This would be, you at least have to have this as your answer. But it can be simplified a little bit more to get this. Okay, determine solutions for this equation. So this is something, what you need to spot first is that this cannot really be simplified. For instance, if we had something like 3 to the 2x minus 1 plus 1 equals 8, obviously this is not the question, but because there's a plus 1 here, this has to be, we have to simplify this a little bit. Otherwise we're going to try to do something and we're not going to be able to make any more progress. So this is already set up to solve. We don't need to simplify it. We can't. So this would then be take logarithm of both sides. So I would say either use log, log, which in this class is, of course, base 10, or ln, which is base e. So same as the last question with the doubling time, should use either one of these. In the solutions, we used log base 10, so I'll do that here. Just be consistent, but you would get the same answer. It doesn't matter either way. So if you do that, 3 to the 2x minus 1 equals 8. Log of 8. Do that on both sides. Now, there's no numbers multiplying the 3. I don't have like a 6 times this number or any other expression here. And so what I can do is take the power and I can move it in front. If there was something else in front of the 3, that can't be done. But it can be here because it's not there. And so then what we're left with the logarithm rule is 2x minus 1 times the log of the base that's left over, which is log 3, equals log of 8. Now, these are just numbers. This is a linear equation. There's only one instance of x. And so the strategy is there's a couple of different ways you could do this. I think it's easier to divide by this value first. If you don't, you have to do a little bit more simplification. You don't have to, but if I do this, then I have log 8 over 3. Now, just a number on the right-hand side. The next step would be to add the 1 over, so it cancels out on the left. So 2x log 8 log 3 plus 1. Then I would divide the whole thing by 2. And you have to be careful that you do everything. This would mean that the solution is then log of 8 over 2 log 3. I can kind of absorb the fraction here if I want, or you could leave it as log. Some students do this all over 2. That's also fine. Either way, it doesn't matter. And if you want decimal, it's 1.4464. It's approximately. So this would be your answer. I would encourage you to try to leave it in exact form until the very end. If you start to work with these decimals from the start and you start to throw these in, you have a high chance of rounding too much and being too far off. You also have a good chance of not knowing what number you're at, or what number you're working on at the moment, and then doing something incorrect. So I really encourage you to leave it in exact form until the end, and then find the decimal if you need to find the decimal, which we had to do here. Okay, moving on. We have a function, and there's some transformations that are being applied. These are all different, right? They're not impacting each other. They're all separate questions, each part. So if we shift it left by 4 and up by 5, so if we want to shift left by 4 and go to the left, that means we add 4 to the inputs, so f of x plus 4 plus 5 does the shift. And then in terms of what the function is, this is the square root of x plus 4 plus 5. Because f of x is the square root of x. And then the next one, stretched vertically by a factor of 4 and reflected over the x-axis. So there's two things that are happening here. One of them is that you're vertically stretching it by a factor of 4, which means you would multiply all of the outputs of f by 4. And so it's 4f of x. And then what about the reflection? If you want to move it across the x-axis, you have to multiply all of the outputs by -1. And so this is a -4 f of x. The negative needs to be there. And then this is -4. F of x is a square root, so -4 root x. And then finally, compress vertically by a factor of 5. There's no reflection, so it's just 1/5 f. And then I want to shift it left by 2, which means I have to add 2 to the input, so f of x plus 2. And then I shift it down by 1 is subtracting 1 from all of the output values. And then this is 1/5 square root x plus 2, again, because f is the square root function minus 1. Okay, these graphs are given, there's obviously 8 choices, only 4 graphs, so not all of them are going to be used. And this is not really a question about quadratics. You could think about it like that, but we also know that just like the function y equals x squared looks like this, and all of these are then transformations of that function. And so that's really the point. Like, yeah, you could think about like vertex form and all of that, but then if that works, congratulations. But really the point here is to note that all of these are transformations of the same function, and then to determine what graphs go with which. So for the first one, if we so all of these are going to be talking about any transformations I write are going to be based on y equals x squared, the original function. And in this case, this is a shift right by 2. I just bump it over 2 on the x-axis. I don't scale it. I don't do anything else to it. And that would then correspond with b, because shifting right by 2 is x minus 2 squared. The function at x minus 2, and the function's x squared. So x minus 2 squared. Then for the next one, I'm now shifting it left. So this is a shift left by 2. It's going from 0 to 2. Again, referencing y equals x squared. And then I also reflect it. It's now going the other direction. And reflected over the x-axis. And if I want to reflect it over the x-axis, I have to multiply the function by -1. And so this is negative x minus x plus 2 squared, which is option E. So this is E. It should be plus 2. Negative x plus 2 squared. For the other one, I'm not shifting it left and right. I am shifting it up. So this is x squared plus okay, well, I need to be careful about that, because scalings and reflections happen first. And so this is negative x squared. I reflect it and then I shift it. Remember, because we have an order for how this is done. So this is actually negative x squared plus 2, and that's option G. And then for the last one, G. Yeah, G. And then for the last one, I'm not scaling it. I'm not reflecting it. The only thing that's happening here is that it's being shifted down by 2. So this is a shift down by 2. And so that's x squared minus 2. So this is option D. I guess for the other one, I didn't write this in. This is reflected over the x-axis and shifted up by 2. Just be careful about the order here. The reflections have to happen first. Scalings happen before shifts. Okay, so moving on. Condense the expression into one logarithm. In order to do this, this is pretty much using the reverse steps of the question where we expanded it. The first thing you have to do is move any coefficients to be powers of the term inside. They can either be, so then what would be left would either be 1 or it could be -1. It can't be 2 1/2. right? So I can write this as log 3 of x squared plus log 3 of y to the 1/2 minus log 3 of z. The minus is fine. You can leave that. These two terms combine. I'm adding them together so I can multiply their terms, which I knew to do because I want to go to one logarithm. I need to start putting these together, and that would be how I would do it. So x squared y to the 1/2. And then I still have this term left on the right, the minus 3 minus log 3 of z. And if I subtract them, then I divide the inputs. So log 3 x squared y to the 1/2, and I can divide that by z. And so all these are equal. This would be my answer. Now you could rewrite this if you want as log base 3. You can say this is x squared square root y over z, because y to the 1/2 is the square root. Okay, last question. Given the function, state the original function, and then describe in words what transformations you applied. This is slightly subjective to what you pick. I think there's kind of an obvious choice to pick for the original function, but of course if you pick something else, your transformations that you list will be different. But I think it's kind of clear that the original function for what you started with would just be x squared. And then the transformations done would be what? Well, I added 3 to the inputs, so we have to do horizontal scaling and reflection first, which there isn't any here. The next thing I have to look at are horizontal shifts, and there is horizontal shifting. I'm adding 3 to the inputs, which means I'm shifting it left. So it's shifted left by 3. Then I multiplied it by the -2. So that's a reflection across the x-axis. So this is reflected over the x-axis. Then I vertically scaled it by the 2. That's what the 2 is representing. But I'm multiplying it by the 2, so the outputs are getting bigger, so it's being stretched. So it's being stretched vertically by a factor of 2. And finally, we're subtracting 4 from the function, so it's shifted down by the 4. Notice it's not shift down by -4. That doesn't make any sense. These shift values should be positive. The adjectives left and right, up and down correlate if they're even or odd, or positive or negative in the formula, but you need to have these values be positive. Okay, that's the last question, I believe. Yes, okay.